Hello everyone. Hello everyone. This is Vishal Sharma, group owner and moderator of the Carrier Ethernet group, back again with another episode of our network design and architecture series, which is what I'm calling this. And really, my purpose here is to take some of the most important, some of the most useful discussions on the group, and once we've come to some kind of conclusion, summarize them in a little video and a little discussion with you all. And the purpose is really that when you look at a discussion with maybe 50 or 60 comments, it becomes almost impossible to kind of make sense of everything that was said there. And of course, everybody interprets those comments from their own perspective, and of course gleans something from that process. But what ends up happening is it's sometimes very difficult to see a holistic overall picture of all of the various things that the discussion touched. So the purpose of these videos really is to bring those key points, as at least as far as I understand them, to bring that distillation out to the group, to the community, and provide a background and a context and all of the different components that I think that discussion touched, so that you can then go take this forward and apply it, no matter whether you're a network architect or network engineer, you're a system designer at a vendor, or a product management person trying to at an operator trying to sell a service to a customer. Or are you selling maybe vendor products, whether be they software or hardware? So that really is this purpose behind this these videos here. And in deference to my friend Azhar Khwaja, who asked that I always have an outline, let me do a screen share with you all and show you an outline of how these videos are going to go. So I have actually put an outline together, and you're going to see it in 1 minute, and there you are. So the outline for most of our Google Hangouts that I'm covering this in the network design and architecture series is going to be going to go as follows. First and foremost, I got to tell you what discussion or issue it is that we are focusing on, and I have to show you where and how you're going to find that discussion, because that can be a big challenge in LinkedIn many a times. And then, as always, we'll give you some background on the subject, where to find that background, and then I'm going to do a deep dive into the actual discussion, the key topic, where we'll talk about the key issues that were discussed in the discussion, what were some of the highlights that came out of it, what standards, documents, or other industry documents, white papers, and so on could be useful for studying the issues. And finally, I'll close out with some conclusions and maybe open issues and next steps. And the next steps could be about how you can contribute to the discussion, how you can get involved, and how you can add to this or share your own experiences as you start implementing some of these principles. So for the specific discussion in question, let me take you back to the mind map that we've been talking about in the last couple of videos, and start there. So, oops. Still working out a few of the kinks in Google Hangouts. All right, so everybody who's watching this should now be able to see this mind map that I'm showing you guys. All right, so this was a mind map that covered the weekly updates till about a week back, and there was some interesting traffic management and QoS discussions there. And today we are focusing on this specific one, where Saurabh Agarwal of Arison Technologies had asked a very interesting question. And basically, the bottom line question was, how can we monitor the overall service uptime in a multi-point to multi-point carrier Ethernet service? That is really the essence of Saurabh's questions. And let me tell you a little bit about what the various components were that this discussion actually ended up covering. So let me tell you first, this was the discussion and the issue. It's linkable and easily navigable from the mind map. So if you just right click on this link here, as I'm doing, when you get the actual document, and you can open the link outside of the document, and when you right click on it, the discussion will come up, and you'll be able to actually follow the discussion if that's what you wanted to do. So some of the background that is useful to talk about this is shown here on my mind map. In fact, I've connected it already. So let's open that up. So there's a bunch of MEF specifications, as you might imagine, that are extremely useful. And I've linked 3 in particular, and I have to thank Fred Huffman for pointing out some of the MEF 35 standards and their updates in the course of this thread. So the first thing you might want to look at is the Service OAM framework and requirements, which is MEF 17, which kind of gives the framework for how MEF thinks about Service OAM to begin with. And it's a good introduction if you want to look at the subject. And then specific to performance monitoring, there are 3 MEF documents that are interesting to look at. And I have not only linked the document, I've also linked a summary presentation that's also available on the MEF website. So sometimes you might want to actually look at that. And you want to look at MEF 35, the first implementation amendment, which was MEF 35.01, and then the second one, which is MEF 35.02, which all talk about setting various thresholds for measuring different kinds of performance parameters on Metro Ethernet network that's carrying various kinds of services. So now the specific question of what was discussed by the various contributors on this discussion. So let me first give you a quick highlight of what the different points were, and then we'll do a deep dive and actually talk about them one by one. So what ended up happening in this discussion was that people essentially made a comparison of flow-based technologies, which are primarily layer 3 based technologies, and L2 based, OAM based technologies. And there was a discussion about their suitability for doing various kinds of measurements, and in particular doing uptime measurement. Then we asked Saurabh for what exactly his goal was for doing these measurements and what his network setting was. And thanks to Fred for bringing that up. And so that kind of sets the problem context. And then Saurabh articulated some difficulties that in his mind were going to complicate this whole process, particularly because he was looking at multipoint-to-multipoint services. And then we immediately dived in to a discussion of the solutions. And I must mention that a number of contributors, about 7 or 8, have given their thoughts to this discussion. When you actually go to it, you'll see that it's Stephen Hope, Ishkan, Emeka, Chandra, Malela, Fred Huffman, Marcus Freeman, Dan Martin, and of course Saurabh. These were all of the people involved, and I had also chipped in a little bit, primarily motivating them to put this up on the MEF wiki. So then we got a different perspective from all of the different contributors. Fred talked about a top-down and a bottom-up approach that you can use in something like this. Chandra, coming from a hardware perspective, talked about a very pertinent question, which is how do you measure uptime, and how do you in fact collect that in a hardware system? What are some of the limitations of doing that? Emeka and Ishkan gave some ideas for simplifying measurements. Stephen gave a lot of practical suggestions from his experience about issues that you need to keep in mind, caveats and gotchas. And then Fred brought in the relevant standards, MEF 35 that I just introduced. And then at the end of it, we came up with some bottom line conclusions to the whole discussion. And there's still some open questions that have to be looked at. So let's dive right in and start right out at talking about a comparison of some flow-based and OAM-based technologies, which is kind of independent of the basic discussion, but is interesting to talk about. So I'm going to refer to my notes here, and I've been making some notes so I can walk you guys through what I gleaned from this discussion. So the flow-based technologies are things like Netflow, sFlow, and IPIX, and they basically work on individual flows. So they aggregate statistics, and that you get are obtained by sort of summing the statistics of the individual flows, and they are fundamentally done for traffic analysis. So you basically get traffic details, and it enables you to characterize the traffic in your network and to understand network behavior. That's really the goal. And they are optimized, therefore, for things like capacity planning, for traffic analysis, for security analysis, and stats collection for usage billing. But if you look at the Ethernet OAM standards, the 802.1AG, 802.3AH, and Y.1731, which comes from the ITU, they are primarily designed to measure things like availability, reliability, and perhaps also overall traffic stats in the form of measuring, let's say, the network load. They do work for aggregate traffic because you're not measuring individual parameters here, that is maybe being carried by a common bearer. And what you really want to look at there are service OAM standards and link OAM standards, which the MEF and different the IEEE have specified. Now, SOAM, I'm going to abbreviate service OAM as SOAM. SOAM in particular is optimized for L2 services and measuring L2 parameters and really keeping track of SLAs. So that seems to be kind of aligned with what Saurabh is looking to do here. And it is assuming, of course, that your carrier Ethernet service is offered over an Ethernet network. If you're offering it over an L3 network, it would depend on what you're doing. If you're doing it over VPLS, some of the same techniques might apply, but you might have to supplement it with L3 monitoring techniques as well. All right. So those were kind of the initial discussions that divided how flow-based and Ethernet OAM-based technologies are different and have different purposes. And then we dived into asking Saurabh, all right, Saurabh, what's your goal here? And what's the network setting in which you're looking at? So it turns out that the specific question came up in the context of an enterprise network where it has a mix of PBB and SDH technologies, and it's supporting a mix of Ethernet capabilities, 802.1AD, 802.1Q, and 802.1AH. And Saurabh's ultimate goal is to create a fully automated service assurance solution for Ethernet services. And what does he mean by that? He means that he wants to be able to measure the utilization on the PBB network. He wants to actually measure service SLA parameters such as one-way delay, packet delivery ratio, and uptime for various kinds of Ethernet services on this network, E-line, ELAN, and E3 services. He wants to be able to do automated root cause analysis, and finally, a service impact analysis, by which he means that if a node or a link is down, what are the circuits that are affected by that? So this is really his goal, and this, as I said earlier, sets the problem context. Now, because he's looking at a multi-point-to-multipoint environment, Saurabh articulated certain difficulties, and the primary one was that if you're going to use, let's say, the continuity check messages, the CCM messages, you would have to do them pairwise across all of the endpoints in this MP2MP network, which can be cumbersome. It requires a significant amount of data consolidation and correlation. And what Saurabh was wondering is if that's the only way to do it. Now, I'll give you a little bit of a bottom line here, that indeed, to the extent that we could, in this discussion, determine, it seems that that's really the only way you would do it, at least for the time being. And then there are various levels of detail as to how much and how long you're going to measure your parameters to be able to come up with appropriate uptime measurements. Right? So I think the next thing we began to dive into was solution approaches and issues. So the first thing that I want to highlight is that Fred came up with kind of a high-level approach and asked Saurabh, all right, if I was going to really do this at a very high level, the way I would do it is I would he asked Saurabh whether he's looking for a summary of what's going on in his network, or is his goal to identify all the trouble spots over a given timeline, such as a week, a few days, a month. And based on what I just told you about the problem setting, we know now that ideally Saurabh would like to find this over a timeline. So his objective is not just a high-level analysis, but rather to be able to do a root cause analysis, to go much deeper into what circuits are down when certain nodes or links are failing. And then an approach that Fred suggested was, guys, I do it in a top-down and a bottom-up manner. First, I'd ensure that the facilities and the original service met the performance objectives. And I would do that by testing the circuits at commission time. That would be kind of like a top-down approach. And then once the service was in place, I'd provide a structured monitoring and performance reporting system, again, in line with the things available from the various vendors and perhaps some of the test manufacturers and the software NMS, EMS manufacturers and software software companies, to create a bottom-up approach where now you're monitoring these circuits, you're trying to measure performance and correlate that to performance objectives that you've set up for the network and that you've committed in your SLAs. And then periodically you do that and you see whether you're in sync or out of sync with those metrics. So that was, I think, a good way of looking at the problem. And then Chandra Mulela, who really comes from a hardware background, pointed out to a few interesting questions. And his question was, what is the mechanism that we use to measure uptime? And it seems that CCMs monitored over some appropriate time interval is the way to go. But then the question still remains, how long of an interval should we use? And what is the time period over which we calculate that? And interestingly, Chandra actually pointed out that no matter what kind of aggregation technology you're using, you're ultimately collecting statistics at the hardware level somewhere in a device, and there is a limit to how many statistics and how long aggregation you can do. So first and foremost, you need to be cognizant of the fact that the time period over which you aggregate statistics is going to be limited by what is available in your hardware counters. So of course you can use a sequence of small time periods over which you'll collect the stats, but every single small time period is going to be limited by how much your hardware can accumulate at over a given interval of time. So that's like a good benchmark, whether you're a hardware designer or whether you're a network architect who's trying to define intervals over which you want to collect these statistics and eventually aggregate them, perhaps in the NMS or the EMS. And the other thing Chandra pointed out is that service quality can be correlated to loss, and we can measure loss on a circuit in terms of the number of packets that weren't received and so forth, but it doesn't necessarily correlate to uptime, because you can have a lossy service and still have the Ethernet network and the Ethernet connection be up. The loss can be due to some other reasons, buffer overflows, a police are discarding traffic and so forth, that have nothing to do with the service itself being up. So if you were to try to correlate loss to service uptime, you have to be a little bit careful, because the two don't necessarily go together. And if you are using them as a proxy for one for the other, you need to know to what extent you can rely on loss to be a measure of uptime. Now, Emeka and Ishkan made, I believe, some useful suggestions about how you can simplify measurements. So recall that one of the problems for Saurabh was that you'd have to do a lot of pairwise endpoint to endpoint measurements to collect the statistics to determine the overall uptime of the multi-point to multi-point service. And so there were two suggestions to simplify this. One is that one can reduce the measurement to some subset of ordered pairs of endpoints over which we do the measurements. So not every single pair might be required. You might selectively do measurements over some subset of ordered pairs for some period of time, and then another different maybe subset of ordered pairs for a different period of time. And the other thing was that you can correlate EVC uptime to an availability metric of the EVC. And that can be based on basically service frame loss, keeping in mind the previous caveat about relating loss to uptime. And that service frame loss is measured between subsets of pairs of unis in the multi-point EVC, in accordance with some of the specifications in MEF10.x series, 10.1.2.3. And so that I thought was a good idea and a good way of looking at it. And so now the question is, what does availability for a how do you get availability for a multi-point EVC? So of course you have to do it in terms of pairwise measurements. And then availability for a point-to-point EVC has been defined in the MEF via service frame loss over some period of time cap t, or a sequence of small consecutive intervals, let's say delta little t, that comprise cap t. So as you can see, this is kind of an elastic definition of frame loss that the MEF has come up with, and it allows you to, gives you a lot of flexibility in how you define availability for an EVC, but it doesn't give you any specific numbers with which to correlate availability. And here, Marcus Freeman of Netflow brought in something from the ITUT Y.1563 specifications. And what Marcus showed, and let me actually find that here so I am accurate in what I'm going to say, is let me see where Marcus's comments are. Okay, LinkedIn takes a little bit of time to upload because we have a lot of comments, almost 40 comments on this discussion, which takes a while to get to. So let me see where Marcus is. Let's see if I can actually find Marcus by looking for his name. There you go. So what Marcus pointed out is that Y1731 does provide a definition for availability for Ethernet in particular. And they basically have the concept of severely errored seconds. And if you have more than 10 consecutive severely errored seconds, you trigger unavailability of a circuit. And if you have 10 consecutive non-severely errored seconds, you trigger availability of the circuit. And the question then is, how do you define when you have a severely errored second? And the Y1563 standards say that a frame loss ratio of 50%, which occurs over 1 second period of time, is enough to designate a second of traffic transmission as a severely errored second. So this value, of course, can be changed. And as we see when we try to correlate this with the MEF definition, the MEF definition is flexible and elastic, doesn't really lay down a specific threshold, where the ITUT 1563 definition does. And so maybe there's some common ground that can be obtained by actually specifying a specific definition for when you might have service unavailability. So the next thing the discussion focused on was, are there relevant standards that relate to this? And I already pointed out that MEF 35 and the 35 amendments have, according to Fred, several definitions of thresholding of availability. And you would actually have to look at the details to see what the standards actually say. But they provide some guidelines on that would again help to relate availability to uptime in the manner that Ishkan was pointing out. So then again, the question is, what are our bottom line conclusions? So the bottom line conclusions, when we go back to answer the basic question, which was, what is the best way to measure service uptime and monitor overall uptime for a multi-point-to-multipoint Ethernet service? I think what this discussion concluded was, number one, that the Ethernet OAM standards are probably the most appropriate ways to do that for doing SLA-based measurements, especially in a multi-point environment. The flow monitoring that is done is more for traffic aggregation and analysis and network design, and isn't really appropriate. The CCM-based uptime is the most suitable, even though we do realize that you need to define a threshold of time over which you're going to do CCM and measurements and average them, and that you do have to correlate multiple pairwise endpoints, which is cumbersome, but that is the only way we can do it at this point. And the reason you need that, as something Saurabh pointed out, is that the CCM-based uptime checks, the remote MEP alarms don't actually qualify which end is down. So as a result, you have to consolidate all of the different alarms and you have to correlate them to figure out which end is down. And once you know that, then of course you can take restorative action, corrective action, depending on what has been defined by network policy. And then, of course, the service is assumed up based on your definition of availability, which for the MEF standards is pretty flexible, because it just talks about, just to recap, correlating the availability of a circuit by measuring frame loss over over a subset of endpoints over an interval t, or a sequence of consecutive intervals little t that sum up to capital T. And little t and capital T are not explicitly defined. Or we can use the Y1563 definition, which says that when you have 10 severely errored frames, your service is down, and when you have 10 severely non-errored frames in succession, your service is up again. And a severely errored frame can be correlated to Ethernet parameters by doing frame loss measurements, and when the FLR is 50% or more, you have a severely errored frame. So that kind of sums up the different components that we looked at, right from network design and architecture, the setting of the problem, to the different top-down, bottom-up approaches, to the optimizations one can do to somewhat mitigate the correlation problem, to the issues at the hardware level that one must be cognizant of to define the time intervals for measurements, to some of the caveats that actually Stephen Hope brought up, which I should bring up now. Stephen pointed out very, very insightfully that the loss of statistics is not really a loss of your connection, a loss of service. So you actually have to be cognizant of what happens when you're doing these end-to-end measurements. Well, what you really have to do is, if you're going to measure per service availability in a multi-point environment, you might actually have to collect traffic matrix and statistics. All right, and that's a challenge in itself. And the other thing you have to be conscious of is, what do you do when your measurement system is down? Your service may not be. And how do you deal with the fact that because we are in a packet world and the end user is not transmitting all the time, that your service is down when the user is not really transmitting. So effectively, the user doesn't really see the services being down. Now, if we come from the more traditional sort of TDM world, service uptime is just defined as the circuit being up, whether you're sending something on it or not. But as Stephen points out, when you're in the packet world, it's a little bit more involved. It's a little bit more interesting because you could be transmitting something or not. And if the service is down while you're not transmitting something, the end user is really not affected by that. And all of the discussions we've done so far don't yet account for it, which brings me to sort of the open questions that are still remaining at the end of all this discussion. One is, as you've observed, is what is the time period of uptime calculations? And there is a certain guidance given from the severely errored frames of the ITU, or if you look at the hardware level, a guidance may come from how long of a period you can actually keep accumulating stats over in a hardware counter somewhere in your router switch system. The second is, how do we treat temporary loss of the statistics collection system itself? What do we do when that happens? And then how often does the polling system lose data? How frequently is that? I mean, that can happen when an end device buffer overflows or a counter overflows. And so what do you do in that case if data is lost? How do you account for that? Is the network up? Is the system up or not? Is the service up or not? That depends on what policy or best practice we decide to evolve. So that pretty much brings me to what I wanted to say on this topic. Once again, you can find the link to the clickable mind map below the discussion. And when you click on it and you go to specifically the green discussion, which is Saurabh's discussion, you'll find the references. You'll find the reference to discussion on LinkedIn. And one thing I also wanted to share with you guys, and let me do a screen share again quickly before we conclude, is that there is in fact an NEF wiki page that the folks have already put together that is in progress and serves as a great way for us to start summarizing in print some of this information. Now, let me see why I don't have that. One moment here. Actually, if I have multiple tabs open in a browser, I realize that Google Hangouts will only show me the tab that's active. So if I have a tab that's not active, which was the case with this wiki page, I actually don't see it for a screen share. So there you go. So we've titled it Service Uptime in Ethernet Networks. This is, again, a link to this is available from the mind map, so you will easily be able to find it. And just to give you a bit of a structure, every one of these wiki pages is designed to give the description of the problem in this main body. Then we have a list of open questions. And we also have a list of recommendations, which are kind of like the conclusions I talked about a little while back, which tells you what best practices people have concluded are applicable right now. And of course, we can extend them over time. And it also has a list of all the contributing authors, which you see on the right-hand side, and a link to the actual LinkedIn discussion for those that are interested and actually want to follow sort of the details of what was discussed. So this is a great initiative. Thanks to Daniel Barlev of the MEF for hosting this wiki page on the MEF website and making it available to the Carrier Ethernet group members. I think we as a community and of course the authors themselves need to work on putting the best distilled information there that we can. This video I'm just making is a step in that direction. And so I think this is one of the ways we can start bringing important information from the group to the community at large, to people that may not have time to read 50 discussions or 50 comments. And even if they did read them, it's kind of difficult, as I said earlier, to come to all of the conclusions and to see all of the various perspectives. So my hope is this has given you a bit of an insight into all of the different things that this discussion actually touched. It motivates and stimulates some thinking as you think about these problems, and it'll also motivate you to come back and share your experiences or your best practices on the group, either as part of this discussion, as part of our handouts, or as part of a new discussion that you might initiate yourself. So thank you very much again for watching. Until next time, may the bits in your bytes and the bytes in your packets be profitable. And I'll see you next time. Bye-bye.